problem 2, and we need to calculate the rate of placement for concrete for a section of shear gore on the 12th floor of a high-rise building, and assume the distance from the ground to the top of the gore is 168 feet. A tower crane using 2 buckets, each with a capacity 1.5 cubic yard, has a rate of travel 60 feet per minute up, so that is basically the speed. And with the empty going down, it's the speed is higher, so 120 feet per minute down. Assume the pickup time is 20 seconds, so go down, pick up the bucket, and then the dump time is 5 minutes on the 12th floor. And the placement condition now, the gore height, they give us the gore thickness 10 inches, gore height 14 feet, and the gore length is 60 feet. And why we need to determine the rate of concrete placement? In the next few lectures, you will learn to design the formwork. And the formwork design based on the pressure of the concrete on the formwork. And the pressure of formwork will depend on the rate of placement. So if we increase the rate of placement of concrete, then as you can see, the pressure will be higher. So that for this one, we determine the rate of the placement, and next lessons, we will be able to determine the concrete pressures that depends on the rate of placement that we do for this lesson. So let's work on this. So as you can see, the first we need to see what is the rate of delivery in this case, and what is the volume of the concrete for the gore that we need to find out. And from that, two components, we'll be able to determine the time required to place, and then we can go to the final step, determine the rate of placement in the feet per hours. So, and like I said, the purpose to determine the rate of placement is in the next lessons when we learn the design, the formwork, we need to find out the pressure of the concrete, and that is a function of the rate of placement that we determine, for example, in problem 2 in today's lesson. So first, to determine the rate of delivery of this bucket and tower crane, and before we determine the rate of deliveries as we did in the previous lesson, we need to find out the volume per cycle, and then we find out the cycle time. So with that, cycle time for how what is the cycle time for the bucket from the pickup go up to the 12th floor, and then dump and go down to pick up another bucket. So that is the total cycle time we have. So total cycle time, and it equal to the pickup time. So you can have 20 seconds if we determine the cycle time in minutes. So it will be equal to 20 seconds for the pickup time divided by 60 second per minute, as you can see there, second per minute, to find out the minutes. And then pick up, then go up, then the we know speed, we know the distance, so for the time it will be distance divided by the speed. So 168 feet divided by 90 feet per minute, and this is feet. And then dump time 5 minutes, and then go down 168 divided by 120 feet per minute, and all the unit for 4 components here are in minutes. So from that we can get the answer at 8.6 minutes. So the cycle time for the bucket from the pickup time to go up to the 12th floor, and then dump, place concrete, and going down to pick up another bucket, that 8.6 minutes. And one cycle time is 1.5 cubic yard. So from that we can see the something we talked before, production rate or production. Then this one we can say that the rate of delivery for the concrete, rate of delivery concrete from ground to the 12th floor. So we already know it will be the volume per cycle 1.5 cubic yard divided by cycle time 8.6, and if we talking about per hour, so we time 60 minutes per hour, and this in minutes. So from here we can get the 10.46 and the unit cubic yard per hour. So place concrete in this case we can deliver and place 10.46 cubic yard per hour. So we know the rate. To find out the hours, we need to find out the volume of concrete for the goal. Volume, the quantity, basically. And the goal size are given 14, the height, the thickness is 10 inches, and the length is 60. So we have, will be 14 times 10 divided by 12, just unit conversion, and then 60, and that it will be cubic feet. If you want cubic yard, then divide by 1.1/27. So we have the volume concrete needed 25.93 cubic yard. So we see the rate of delivery 10.46 cubic yard per hour. Volume of concrete for this goal is 25.93. So we can be able to determine the time required to place this volume. Time require to place 25.93 cubic yard of concrete. We know the rate, we know the volume, so we just divide. So it will be 25.93 divided by 10.46 cubic yard divided by cubic yard per hour. So yes, we can have the 2.48 hours. And this is not the question asked yet. The question asked what is the rate of placement. And for the rate of placement of the goal, it means for the pressure, if you have the concrete here, the goal, place the concrete, assume that it's concrete. So the rate of placement is measured by how many linear foot per hours that we have, the rate of placement. So if you, so we have placed concrete, it go from bottom to top, right? You see, we have the placement of concrete, and from that the rate, it will be measured rate of placements of concrete. It measured by the height divided by the hours. So what is the unit? It will be feet per hour. It takes 2.48 hours to finish the goal with the height is 14 feet. So what is the rate of placement? So we can be able to determine, okay, so for 1 linear foot of height of the goal, how many hours will it take? So that basically the process to determine the rate of placements. So finally, the rate of placements in feet per hour. And with that, we have the 14 feet height. Of the goal. We divide by the number of hours required to finish that goal, which is 2.48 hours. From there, we will get 5.65 feet per hour. And as you can see, if that number increase or decrease, it will affect the pressure of the fresh concrete on the formwork. And that's why we need to determine, yes, to determine the pressure. And when we have pressure, we know the load to determine, to design the formwork. That will be discussed in the next few lessons. So keep that in mind, why we need to determine the rates of placement and how we can do that in this problem.